So we all knows that in yesterday's class we have calculated what is the principle of flotation. So principle of flotation. So if you take basically any kind of object, either it is a sinking or floating, doesn't matter. So always there will be actually. So what will happen, everyone? Let me take whiteboard. So if I take everyone, so either object will sink, any kind of object, either it will sink or float, or you can see that you all in that based upon the liquid density, it will either sink or float. Am I right, everyone? Please respond, all of you.
Yes, sir.
Correct or not? So if you all see that, if I take any kind of a liquid, if I take, yeah, if I take any kind of liquid, can you able to see my screen, everybody? All of you?
No.
No. Yeah, 1 minute. 1 minute more. It's okay. Hello. Can you see it now, everybody?
Yes.
Yes, sir.
So now if I have taken any kind of object, we all notice it. Either it will sink or float. It will sink or float in the given liquid. I have given you some substance. So this substance, maybe it will sink in the liquid or it will float in the liquid. It depends on two things. One is density of the substance. This is the density of the substance. That is what we used to say sigma. Density of the substance. And it will also depends on what? Rho. Rho means what? Density of
Density of the
liquid. So if you have noticed before yesterday's class we studied, basically if I take any kind of object which is inside the water, partially or completely immersed in the water or any liquid, so always there is a force which is acting downwards. What is that force, everybody? Which is equals to weight of the object. That is what? Mass of the object into acceleration due to gravity. And there is a force which is always acting upward direction. What is the force we used to call it as, everybody? Yes, please. Upthrust, or we used to call it as a what? All of you? Buoyant. Understand? So now we have a three cases. Yesterday's we have seen. One is object will completely sink. It will go and will settle at the bottom. So by that time also it will experience two things. One is weight of the object. Another one is buoyant force in the upward direction. So which is greater? Weight of the object is greater or buoyant force is greater? Everybody, sinking case, all of you. Weight of the object is heavier than the force, buoyancy force experienced by the liquid. So that object will sink or float. Everybody, object will sink. Clear? Next, another kind of liquid, the object is floating above the surface. Above the surface. Now also weight of the object is W, buoyancy force is upward. Now it is floating above the surface. So that who is greater? Buoyancy force is greater or weight of the object is greater? Everybody? Buoyancy force. So buoyancy force is greater than weight of the object, so that it will float. It will float above the surface or below the surface? Above the surface. That is what you have to remember. Next case, if I take another one, all of you remember. So object is not settled down, neither settled down nor coming up. It is just below the surface, it is there. So now in this case also weight of the body is acting downwards and it is acting, buoyancy force is acting upwards. But here what is happening, everybody? It is just along with the liquid, it is floating. So what we can say is buoyancy equals to weight of the object. That is what you have to remember. So these are the three cases related to force. Understanding? Buoyancy force and weight of the object. But yesterday we have seen, we have found the two formulas for upthrust and weight. Do you all remember? So what is the upthrust formula, everyone? Upthrust formula. Upthrust is equals to, what is that, everybody? Weight, yeah. Weight of the liquid. Weight of the liquid. Please respond. Display. Weight of the liquid displays. So weight is equals to what? Everybody, mass into
G.
acceleration due to gravity. So mass can be replaced by density formula. Can you tell me mass is equals to what, everybody?
Density into volume.
Density into volume. Volume of what? Volume of what? Volume of the
Liquid.
liquid displaced. So what we assumed volume of the liquid displaced yesterday's class? V1.
V1.
Volume of the liquid displaced is V1. So in place of mass, I will represent density of a liquid into volume of the liquid displaced into G. So this is the formula for what? Everybody? What is the formula?
Upthrust.
This is the formula for upthrust.
Sir,
Understand?
sigma V1G.
Yeah, that is for weight. Understand, Mari? So this is actually the buoyancy force. So buoyancy force is equals to what, guys? Rho V1G. What is rho? Rho means what? Density of?
Liquid.
Density of. Yes, please. Density of what, Nivedan?
Liquid.
Density of liquid. What do you mean by V1? V1 means what? Volume?
Volume of
Volume of liquid.
Understanding? Yeah, volume of displaced liquid. That is what it is. Next, there is another force which is acting downward direction. That is only ways to call it as, everybody, weight. Weight is equals to what? Weight is equals to what? Mass
into
of
acceleration.
object. Mass of object into G. So mass of object means what? Mass of object is equals to density of object into volume of object. So what do you mean by sigma? Sigma means what? Everybody?
Density of object.
Density of object. And what do you mean by V? Volume of object. Volume of? Volume of? Please respond. Volume
So
of?
one doubt, sir.
Yes.
Sir, in weight, we are talking about the display density of displaced liquid as displaced
No.
liquid as.
Object, Mari. We are talking about weight is related to the immersed object. Do you understand?
Yes, sir.
Buoyancy force is related to liquid. That is why liquid displaced and density
So
of
we are seeing about the density of
Yes.
substance regarding the weight.
weight. So mass of the object means I can write density of the object into volume of the object into G. So this is the weight, sigma Vg. This is the weight, and rho V1G. This is the buoyancy force. Ellame purima amma? Do you understand, amma, everybody? Please respond, all of you. Ma, displaced object, how you say, ma? Liquid will displace, volume cannot be displaced. Understand, Abhirami? Clear? Suppose you are having one glass of water. If you put a stone, a stone is going down, means the liquid will be displaced. Well, so how the stone will displace? Do you understand? Clear,
Yes,
ma?
sir.
Yeah. So that is what. So that is what you have to remember. Do you understand, guys? Everybody? Yes, please.
Yes, sir.
Now, first case. Let me take this case. Now, object is floating below the surface. Means buoyancy force is equals to what? Everybody? Buoyancy force is equals to what? Weight of the object. Am I right or wrong? Please respond. Everybody? Yes, please. Now, let me take this volume of the solid is. Volume of the solid is V, and amount of liquid. What is the volume of the amount of displaced liquid? Anybody can tell? What is the volume of the amount of displaced liquid? I am
V1.
asking. Displaced liquid is V1. So now I already taught you before, and again I am saying you, the volume of the displaced liquid is equals to volume of the solid. Do you understand what I am saying? Always, whatever the liquid you take. So volume of displaced liquid is equal to total volume of immersed object. Is it okay, guys? Speak, respond, everybody.
Yes.
Yes, that is what means. Can I say V is equals to V1? Everybody, please respond. Everybody clear? That's all. So, first case, we are having a 3 cases. Write everything. FB is greater than weight. So, object will sink or float. Sink or float. Buoyancy force is greater. Float. FB is less than weight, means weight is greater. So, object will sink or float. Everybody. Object will Object will
Sink.
sink. Next, FB is equals to weight. So now object will float. Yes,
Below the surface.
below the surface.
Below the
Below the surface. Understanding? Floating. This is float above. This is float below. That is what you have to remember. So let me take first case. This is the case one. So case one, what? FB is greater than W. So FB is greater than W means upthrust, case one. Upthrust, understanding, is greater than the weight of the object. Am I right or wrong? Everybody, please respond. All of you.
surface.
So object will sink or float? Object will sink or float?
Float.
Upthrust is greater, so that object will float above the surface. So if you want to float, observe very carefully. So I will say upthrust is greater than weight. So what is the upthrust formula? Density. What is that? Rho V1G greater than sigma Vg. So just now I said volume of the liquid displaced is equals to volume of the immersed object. So both Gg will get cancelled, V1 and V will get cancelled. So rho is greater than sigma. So when the object will float, anybody can tell? When the object will float, density of liquid is greater than density of, please respond. Density of object. Clear, everybody? So density of object and density of liquid. Density of liquid. So if density of liquid is greater than density of object, so object will sink or float. Everyone, object will sink or float.
Float.
Everybody, object will float. Understand, Mr. Sanjay, Sam? Yes, please, Mr. Gokul. Everybody. So any doubt, please kindly ask me. All of you understand, Amma?
Sir, can you please show the PDF for the first?
Yes, yes. So see that. All of you. Clear, everyone? Girls?
A bit higher, sir.
Yes.
Yes, sir.
Kavya, understand, Kavya? Alfin? I no need to call. You can say anything doubt, you can ask me so that I'll say that. Hasini Sudhaka? Clear, Amma? Laksha?
Yes.
Okay. So please kindly show interest and learn. Mr. Mukesh Purima Tambi?
Sir,
Princey? Danishka?
Yes, sir.
Next.
Sir, will
Upthrust
it
is
float
less than.
above?
Yes, Mari. Tell me.
Sir, will it float above?
Above surface.
Yes,
Understand?
sir.
Yes. Next. Upthrust is less than the weight of the object. So what is that? Case 2. So object will sink or float up. Check it, everybody. Upthrust is less than. Upthrust is less than the weight. So object will sink or float. Everybody? Object will sink. Understanding? So I will write upthrust. Upthrust is less than weight. Okay, weight of the object. So now you can see upthrust means what is that, everybody? So upthrust means what? All of you, buoyancy force. Upthrust is less than weight. So what is upthrust, everyone? Rho V1G less than this one, sigma Vg. So we all knows that volume of the liquid is equals to volume of the displaced liquid is equals to volume of the solid. So V and V1 will get cancelled, Gg will get cancelled. So density of a liquid is less than object or more than object? Everybody, who is greater? Density of a solid is greater than. Density of solid is greater than density of a liquid. Is it okay, everybody? Yes, please. All of you? Agalya, understand, Agalya? Pranav, Niroshi? Please respond. Anything doubt, you can ask me. Okay. So when the object will sink, whose density must be more? Liquid density or a solid object, immersed object density? Which must be more?
Object density.
Object density must be more, so that what will happen? It will sink. That is what you have to remember. Okay, va? Clear? Yes, please. That is. Next. Both are equal. Why should represent with sigma? Abhirami, that is our choice, Abhirami, because both densities you cannot represent with the rho. Do you understand? If two substances are there, if only single substance is there, you can represent with the rho. If two substances is there, definitely there must be a different notation. For a liquid, that's what. If suppose three substances are there, you can choose some other thing. Do you understand? That is what it is. So I am convenient with this, so that I am taking this symbol. It's not, there is no rule that you have to take it. Clear, Amma?
Yes, sir.
Yeah, that is what. But basically, in a standard books, we'll use this is only sigma or rho. That is what. Or you can use D. Next, last case. Upthrust equals to the weight of the object. So that in this case, what will happen? Object will neither sink. It will neither sink nor float on the above the surface. Where it will float? Arasani? It will
Below the
float
Not
below the
surface.
surface. Understand it? So upthrust equals the weight of the object. Okay, va? Ellame. Upthrust equals the weight of the object. So what will happen, everybody? Yes, please. So upthrust is equals to weight. Okay. So if we make it, so what is that? Rho V1G is equals to sigma Vg. So Gg will get cancelled, V1 and V, because volume of the liquid displaced equals to volume of the object. So density of the liquid is equals to density of a solid, so that a solid will neither sink nor float above the surface. It will float where, everybody? It will float
Below
the surface. That is what it is. Do you understand, everyone? Are you clear? All of you, ma?
Yes, sir.
Yes, that is
Yes,
what.
sir.
So please make it. Any doubt you can ask me. Lingesh, understand? Clear, everybody? Anything doubt you can ask. What happened to this Shivani? I don't. Shivani and that what happened to Hasini, Laksha? Hasini Sudhakar, understand? Hey, Mr. Gokul, are you doing, man? Solving or not, man? Lingesh, Mugesh?
Solving, sir.
Yeah. So these are the three cases. This is only, we can say, principle of flotation. So either the object will sink or float above the surface or below the surface is depends on what? Density of the substance. So keep it in mind, if the density difference is more than, that is what, see that, the difference between, suppose see, the density of the liquid is greater than the density of an object, more and more and more, then immersed portion of the object, immersed portion of the object is less or more. Anybody? Is less. Clear, everyone? Because so there is a greater buoyancy force. So density of the liquid is higher, then buoyancy force is also more and more and more. So that the immersed portion of the object is less. That is what you have to remember. Is it okay, everybody? Now, if density is very small, like you can say, clear, everyone? So if there is a small difference, only there is a small difference, then most of the object is sink. Most of the object is immersed. Most of the object is immersed. Very less part of the object object is above the surface. Clear, everyone? All of you, please understand. Understanding? Like you can take in a ocean. Ocean, there is a icebergs. Do you all know icebergs? All of you? Icebergs. Understanding? For example, tall I am seeing like this iceberg. Bottom, imagine 9 times it is. Like 8 by 9 times of iceberg inside the water. And with the visible iceberg is just 1 by 9th of the iceberg. So if I cut entire iceberg into 9 parts, the visible part for us, which is looks like a floating, is just 1 by 9th of the part. Remaining 8 by 9 parts of the iceberg is inside the water. That is what? Sir, why, sir, majority of the body is inside? Because you can see normal water is 1, let me take basically ocean water it is. So what is the density of water, everybody? 1 gram per cubic centimeter, generally if I take. Now if it comes to the ice 0.95 gram per cubic centimeter. So there is no much difference between the densities. So that is why most of the body will be inside the liquid or outside the liquid. Everybody? Most of the liquid is inside. Do you understand, Sangamitrai, Kavya? Are you clear, everybody? So the density difference is more and more between the liquid and the object, immersed object, then it will experience greater buoyancy force in the case of sinking. That is what you have to remember. For example, if density of a liquid is less than solid, what will happen, everybody? Directly the object undergoes what? Without any hesitate, directly the object will settle at where? All of you? Sink. Understanding? So bottom of the container. That is what is the concept of principle of flotation. I hope you all understand. Anybody having any doubt, you can ask me. Are you clear, guys? Please.
We go.
Yes, Amma? Nothing, everybody. So you can see, all of you, if the density difference with, I will say you examples. All of you see, for example, I take water. What is the water density at the 4 degrees Celsius? We all knows that. Anybody can tell? Water density. Please respond. What is the water density, guys? 1 gram per cubic centimeter. Do you understand it? Now, listen first. 1 gram per cubic centimeter. Now, I said one girl to give an object whose density is 0.5 gram per cubic centimeter. So it will sink or float up. Anybody? It will sink or float. It will float.
So.
Right or wrong? Yes, please. It will float. Definitely above the surface. But the girls noticed that 50% of the object is sink and 50% only it is visible above the surface. Purima, understand? Sam, Gokul, that is what they have noticed. When there is a difference between them is 1 minus 0.5, difference is 0.5 gram per cubic centimeter. That is the difference. Now, another person came and they have given the say another type of material whose density is just 0.1 gram per cubic centimeter. Now also it will float or sink, everybody? It will float. But how much percentage? You can see by that time difference 1 minus 0.1 which is equals to 0.9 gram per cubic centimeter. So what will happen, everybody? The immersed portion will be less or more. Immersed portion will be less or more. Everybody, difference is more. Difference is more. So immersed portion is very, very less. So like they noticed it, most of the object is just floating above the surface. Puri mama, girls and boys, everybody. Any doubt, anybody can understand? Yes, all of you. If there is a density difference, greater the density difference of a immersed liquid and object, that's what the liquid and object, then the immersed portion will decides the buoyancy force. Understanding? So greater the differences of densities, higher it will be the experiencing either sinking or floating, both they will be experiencing the same. So if there is a normal, like very noticeable difference, very small, minute differences, then either the object, understanding, most of the object will be sinking. For example, I will take another object whose density is 9.8. So understanding everybody, so that you can see only entire body is inside, only 1%, understanding, only just 10% of body is visible. So in this case, what does it mean, everybody? So in this case, density of liquid, okay, density of liquid is equals to 1 gram per cubic centimeter. Maybe the density of object is equals to 0.9 gram per cubic centimeter. So what is the difference, everybody? 1 minus 0.9, which is equals to what, guys? Please respond. 0.1 gram per cubic centimeter. This is the difference. That is why you can say most of the object is inside the liquid. Do you understand? Kavya, I'm calling, nothing responding. Sangamitrai, Abhirami, that is what you have to remember. Anybody having any doubt, you can ask me. So the density between the liquid and the object, immersed object, is more and more and more difference. So what will happen? Either the object will sink or object will completely float above the surface. The immersed portion is very, very less. Am I right, guys? Everyone, please respond. That is what is
Yes.
the concept of flotation, principle of flotation. So very, very important. So with the help of these principle only, so we're having many real life applications. You can take it. What, Abhirami? Displaced medium. Displaced medium. I'm not getting, Abhirami. What is your question? You can ask. What is your question?
No, sir, the amount of displaced liquid.
Amount of displaced liquid also will be different. It is not same. You understand? It is not same.
Okay, sir.
Yeah. Clear, everybody?
Yes, sir.
Yeah. Please make it. Girls, understood, Amma? Alfin? What is this, Alfin? Nothing doing.
So
Yeah.
then the difference of density between the liquid and the immersed object will be, and it is directly proportional to the buoyancy force, sir.
Actually, not buoyancy force, Mari. So for example, I'm saying you take two liquids. One is water and another one is, let me take, suppose for example, glycerin. Glycerin is 1.3 gram per cubic centimeter. Water is 1 gram per cubic centimeter. Okay, Mari. Now I took an object whose density, is, imagine, 0.9. Okay, gram per cubic centimeter. Now, if I put in the water, then difference is how much? 1 minus 0.9, which is equals to 0.1 gram per cubic centimeter. So yeah. So this is very less difference or more difference? Very, very less difference. You understand? So
Yes, sir.
now next, let me take here. What is the difference? 1.3 minus 0.9. How much, Ra? What is the difference, Ra? Everybody? 1.3. Yes, please. 1.3 minus 0.9. 0.4. Understanding? So 0.4 gram per cubic centimeter. So which is the greater difference? Anybody? First one or second one? Greater difference. Second one. Understanding? So here, immersed portion is less compared to the first one. Here, immersed portion is high because most of the bodies will be sinking and only very less portion of the body is visible to us outside because of less density difference. That is what you have to understand. Urima?
Yes, sir. So then this
But
is known as the this is known as the principle of flotation, sir.
this is also, yeah, this is also concept of principle of flotation. That is what you have to know. Okay?
Sir.
Understand, Amma?
Yes,
How
sir.
much it is? So how much either the object will sink or float, how much it will float above the surface, that will be depends on the density difference. For example, I will take a boat. I'm having a boat. I design a boat in such a way, having some X density. Now, if I am traveling in a normal river water, all of you check it. I am traveling in a normal river water. Definitely, the immersed portion will be more or less. Anybody can tell? Whose density is greater, salt water or ocean water? Whose density is greater? Everyone, girls, this is let me take a river. Okay. So now another one. I am taking a salt water or sea water. Now, whose density is greater? Density of seawater is greater than actually density of river water. So now, where immersed portion is greater? What you people are expecting? That is what is my question. Where you people are expecting? Everybody. Where it will sink more or where it will sink less? Immersed portion. River or seawater? Everybody? So let
Sir,
me
in river water, it will
no,
immerse, sir.
listen. Yeah. So if I've taken normally, let me take this boat density is 0.8 meter gram per cubic centimeter. So river density water only, normal water. So I will take 1 gram per cubic centimeter. Here, sea water 1.3 basically. 1.3 gram per cubic centimeter. And the boat density is 0.8 gram per cubic centimeter. So where is the difference more? Here 0.2, here 2 plus 0.5 is the difference. So where the immersed portion is less? In the ocean or a sea? Sorry, ocean or a river? Where the immersed portion of the ship is higher? Everybody? Where the
Sea.
immersed portion of the sea, sea is more
River.
immersed portion. No, sea is less compared to the river because here the difference is very, very less. So that immersed portion is more or less. Everybody, please respond. That is what? Ma, if the difference between densities is less, then most of the object is in where? Yes, please, sinking or floating. Most of the object is in immersed position. Is it okay? Wow. Everybody, both are opposite. Yes, please respond.
Yes.
Yes.
Yes, sir.
Yes, that is what you have to remember. So this is the most important one. So kindly work. It is necessary. We need to do it. Understand?
Yes, sir.
Do it.
Yes, sir.
Any doubt, anybody can ask me. So now applications. So applications of flotation, you can take it. So we are having many applications. So already you might be studied the applications of Archimedes principle. The same thing like applications of flotation. So if you have taken flotation, the first application is flotation of ship. So how you are able to make a ship, submarines, cruise ship, this, that, and XYZ, everything is flotation of ship. Do you understand, everybody? So applications of flotation only. So everything is designed. Okay. Everything is designed. The ship is, you can see, based upon the density of the liquid where it is traveling. That is what you have to remember. Okay. So you can see. Okay. Abhirami, whatever you want, you can write. Do you understand, Agalya, this concept? Anything doubt, Agalya, in this? Understand, Ra? Please, everyone respond. All of you?
Yes, sir.
Yes, that is what. So please make sure anything doubt, you can make it. Okay. So flotation of ship. So basically, ship is made up of what, everyone? Ship is made up of metals, big things. But the total average density, because it is having a large space, the space is filled with what? Large space of a ship is filled with what? Everybody? Overall density, that is what we can say. So overall density of a ship is less than water. So that the ship will float or sink. Everybody? Ship will float or sink. Ship will float or sink. The density of a ship, overall density, okay, or the average density. Average density will be less than the water, so that the object, the ship will float or sink, guys. Please respond.
Float, sir.
It will float. Okay. So you have to take overall density. Y means it is having a lot of space, air and all. So if I take this is my ship, entire area present in this, everything you have to take the densities. Okay. So that is what. So always the water density is greater than the the ship average density of a ship, so that the object will float always, all the ship. Now, not glossary summa, icebergs. So icebergs you can see, as I said, second one, flotation of icebergs. Mr. Sam and Sanjay, understand? Gokul Raja, no response. Pranav also. So icebergs. So this flotation of icebergs, as I said, what is the normal seawater density? Anybody can tell? Basically, you tell me what is the density of ice? Density of ice is actually 0.917 gram per cubic centimeter. It's very, okay, slight difference. Now, if I take normal ocean water, you can take, so it is a normal water you can take. Density of water, it is 1 gram per cubic centimeter. Now, if I make a difference, what is the difference, guys? Is it much difference or very less difference? Everybody? Is it a big difference or very less noticeable difference? All of you? Very noticeable difference. Understand? Smallest. So 917. So what is the answer? What is the difference? What is the difference? Everybody, differences between the densities. Everyone? 0.083 gram per cubic centimeter. So that is the density difference. So it is very minute or more bigger difference or very small minute difference. Everyone? Minute difference. That is why most of the object will sink up or most of the object is present above the surface. Everyone? Please respond. Most of the
Above.
object will sink. So the upper part is only, you can see 1/9. Understanding all of you? 1/9 of, sorry, 1/9 or 12th, you can take anything. 1/9 of its volume. So that is what is the iceberg, what you are saying. And down 8/9 times the iceberg is present. That much it is important because there is a very small difference. That is what it is. Understand, Ra? Nivedan? Gokul? Mr. Prudvi? That is what. Next application. Submarines. Terima? All of you? Submarines also same. So you can take flotation of balloons also. How the balloon will fly. That is also same. Next, flotation of submarines also. So if I have taken flotation of submarines. So this is also will work with the principle of flotation only. So this all the things, if you notice it, everything will be working with the principle of flotation only. So this is what is the applications of flotation and the things related to this. So most of the things I covered, and this is what is about this chapter. Then tomorrow we'll solve the NCERT exercise.